Hello everyone. Welcome to this talk on leveraging Argo events and workflows for data ingestion. As part of this presentation, we'll go over how my team is able to process millions of data points using this infrastructure. A little bit about myself. My name is Siri Verma. I'm currently a software engineer at Microsoft working with the cloud security division. Before that, I was working with Oracle on the cloud infrastructure observability. I can say I have around 5+ years of experience working with in the cloud and cloud native sector. In my free time, I love to play around with open source tools and love hiking as well. This is my LinkedIn and email. Please feel free to reach out to me if you have any questions or suggestions regarding the talk. First, let's start with the basics. Workflows. Argo workflows are among the popular way to run long-running jobs on your Kubernetes infrastructure. They start with defining a YAML file where you can either have steps that run in parallel or series, and you can also define a DAG which executes tasks in similar order. And then you can also define volume mounts and then temporary containers as part of your workflow infrastructure. Next, what we have is Argo events. Argo events mainly has three concepts. First is the event source, which can either be your Git notifications, webhooks, Kubernetes resources, messages from SNS, and Azure Queue storages. Then there is an event bus that carries these messages from the source to the destination. And the destination here is a sensor which has some set of triggers that can run some actions. These actions can either be creating Lambda functions or running Argo workflows or or dumping events into your Kafka or storage queue infrastructure or the event bus infrastructure. This is a bit about the Argo ecosystem. Now, let's look at the architecture itself. My team at Azure is responsible for protecting Azure workloads from network threats. And for that, we end up processing millions of network telemetry data points every day. These network telemetry points sit in an analytics store, which is partitioned on time basis. So the granularity is per second, and we have, if there are 36,000 seconds, then we have 36,000 partitions. For each partition, we end up putting, there's a pod that ends up putting this metadata into the message queue. And then there is an event bus, the Argo event bus, which picks up this message and transfers it to the sensor. The sensor, once it gets the message, triggers an Argo workflow which runs on the pod. So the Argo workflow and controller sits in its own Kubernetes namespace, and the Argo workflows are itself scheduled in a different namespace. Now let's take a deeper look at the workflow itself and how it functions. What you're seeing on the left is a JSON payload that is coming to the sensor. The JSON payload has partition and a value, which is nothing but the value that the Argo workflow needs to process. This partition is passed as a value to the YAML file, and that is when the workflow starts executing. There are mainly 4 steps while executing this workflow. The first one is the load marker steps. Now we all know that when there are long running jobs, a failure in the job is expensive. So it is important for us to checkpoint at regular intervals so that the recovery is fast. And this is what this load markers actually does. So it loads all the recent checkpoints for that particular day, and mounts it as a volume so that it is available for all the pods that come up as part of this workflow. Next, for this particular partition, we check if a particular marker with a completed tag is present or not. For example, if the file name with this partition value dash completed is present, that means we have already completed processing and don't have to start all over again. That is when we skip it. If the marker is not present, that is when start we start executing this particular partition. Then a Docker container starts up. The partition value is passed to the container. The logic inside the container starts pulling in all the data for that partition, which might be around millions, aggregates it, and puts it in the final data store. And once everything is succeeded, we finally save this partition value as completed and upload it back to the object store. Now, if there is a new workflow again, it would again download these markers from this object store and check for the completion and determine if it has to rerun and stuff. Now, what we ended up doing here is we have not only efficiently processed the partition data, but we have also protected ourselves from reprocessing the entire stuff. Coming to the benefits, first, we have inbuilt retry mechanism. What I mean by that, so all the Argo workflows come with a retry expression that you can specify. Now with long running, as we discussed earlier, are prone to failures, it is important that we have proper retry mechanisms in hand. And if we have to build this and if the developers have to build this for every workload, it is cumbersome. So that is what Argo avoids. It already gives us this mechanism built into the workflow mechanics, which makes things easier for us. Next, dynamic provisioning. Before we moved to Argo, we had some set of pods that are pre-provisioned and kept in the Kubernetes infrastructure that would take the events and do the evaluation. But what we have seen is 20 to 30% of these pods would always sit empty. That is an immense waste of compute resources. But with dynamic provisioning, what ends up happening is, depending upon the number of messages and depending upon the events, Argo creates the container, creates the pods, and then eventually deletes them once the completion is done. So we can also provision these, now we can provision the Kubernetes infrastructure for other workloads as well. And last but not the least, we already discussed about work avoidance, where by using the patterns that Argo provides, you can avoid reprocessing the bad jobs. To conclude, we first talked about Argo events and workflows, and we talked about the basic difference between them and how they help us how they help us with resilient processing. Then we looked at an example architecture. And finally, we looked at some advantages of what are the capabilities that Argo gives us that makes it attractive to developers. That's it, folks. I hope you enjoyed the talk, and I hope you enjoy the rest of the talks as well. Thank you.